Hi, my name is Muhammad Alif Aiman bin Sobri and I'm going to present the experiment of impact of jet. For the introduction, moving fluid in natural or artificial system may exert force on object in contact with it. To analyze fluid motion, a finite region of the fluid is usually selected and the gross effect of the flow, such as its force or torque of an object, is determined by calculating the net mass rate that flows into and out of the control volume. This force can be determined as in solid mechanics by using Newton's second law or by momentum equation. The force exerted by a jet of fluid on a flat or curved surface can be resolved by applying the momentum equation. The study of this force is essential to the study of fluid mechanics and hydraulic machinery. There are two objectives for this experiment. The first one is to experimentally determine the force required to keep a flat plate at a datum level while it is subjected to the impact of a water jet. The second one is to compare the experimentally measured force with the analytically calculated force from the control volume form of the linear momentum equation. The methodology of this experiment, first one is level the apparatus and set the lever to the balanced position with the jockey weight at its zero setting. The second one is adjust the weight of the jockey, diameter of the nozzle, height of the vane above the tip of the nozzle when the lever is balanced, and distance from the pivot of the lever to the center of the vane. The third one is admit water through the supply valve and increase the flow to maximum. The fourth one is the force on the vane displace the lever where the location of the jockey which restate the lever to its balance position by sliding the jockey weight along the lever. Next is the flow rate is established by collection of water over time interval. The experiment is then repeated with different value of flow rate. Lastly, the experiment is repeated by changing the flat plate with the spherical cup. This picture shows the experiment setup for the experiment. The apparatus in this picture, there are spring supporting lever, jockey weight, tally, vane, jet, the spring cylinder, nozzle, and fulcrum. The result of the experiment is then recorded in table. The table 1 shows the result obtained from experiment for flat plate. Table 2 shows the result obtained from experiment for spherical cup. And this is the formula used in this experiment. The experiment continued by studying the relationship between the force, where F1 is experimental value and F2 is theoretical value. The table 3 shows the relationship between force for flat plate. Table 4 shows the relationship between the force for hemispherical cup. Then the graph 1 is plotted where the graph of force versus flow rate Q is plotted. There is 4 linear in this graph. As for the discussion from the result, as the volumetric rate of flow Q increased, the force resulted from the impact of the jet on both the flat plate and the hemispherical cup is increased. This relation can be seen clearly from the 4 plots accompanied with this report. The result was already predicted from the change in momentum equation of calculating the force, which is called a theoretical value. Some measured value of the jet force show larger value than the theoretical value. This might be occurred for the following reasons, which is the first one is errors in taking the reading during the experiment. The second one is losses in the experiment apparatus. So the error between F1 and F2 of flat plate is equal to 0.1681. Meanwhile, for the hemispherical cup is equal to 0.6982. As for the conclusion, the objective of the experiment is achieved when the force required to keep a flat plate at a datum level while it is subjected to the impact of water jet is determined. Moreover, from the experiment, the result obtained is used to calculate the force. The value is then compared to the theoretical value, and the value obtained from the experiment is slightly different from the theoretical value. Hence, the experiment is reliable. That's all from me. Thank you.